1 2 1 2 1 2 1 2. Weight and balance. This section covers all things dealing with the weight of the aircraft, the balance of the aircraft, and the combination, the weight and balance of the aircraft. In the section on your written, there's going to be some questions about center of gravity, weight, balance, the different effects of weight, and there's going to be some things we got to calculate some stuff. Let's go through and talk about some of this. Start off with some key terms. Here's a list of key terms that are going to be important for you to know when it comes to weight and balance. But the ones that are highlighted, the arm, basic, empty weight, center of gravity, CG limits, CG range, datum, moment, and station, are the things that are going to be most useful right now in this lesson. When it comes to the weight of the aircraft, the more you increase the weight, the more the performance factors are going to change. So this is a list of a lot of the things that can change as you increase the weight. So your takeoff speed, your takeoff run, how fast you climb, the range, your cruise speed can be reduced, and your stall speed can be increased. Now this can be exacerbated if you exceed the max gross weight that the airplane you have. So if you're over the weight, you can put yourself in a position where the airplane is not going to perform safely, which is why it's important that you follow the rules and they're within the weight and balance limits. And those are some of the things that you'll see and we'll calculate later. Now, the balance. Balance has to do with the CG range or the center of gravity range, and the CG is the distance between the forward and back limits of the position of where the center of gravity can be for an aircraft. And the center of gravity is where the aircraft would balance if it could be balanced from a point. When we look at the effects of a more forward CG, so if the aircraft has a CG that's forward of the limit, here's some things that you can have issue with. So longer than takeoff run, real heavy nose, and you'll have a really high stall speed. If the CG of the aircraft is after the limit, you're going to have some extreme control difficulties. It's going to be really hard to control the airplane. It's going to be really violent if the airplane stalls, and it's going to be less stable at all speeds and really difficult to recover from a stall. So just remember, after CG limit, it's going to be really, really hard to control the airplane. All right, example question. If you load an airplane to the most aft CG, it will cause the airplane to be what? We talked about this. If the airplane has a CG that's behind the limit, what will it end up being? It's going to be less stable at all speeds. Boom, less stable at all speeds. You got that one right. All right, if an airplane is loaded in such a manner that CG is located after the CG limit, one undesirable flight characteristic a pilot might experience its airplane will be, well, we know that if it's aft, it's going to be something to do with controllability. We talked about that. Longer takeoff run? Nah. Stall at a higher than normal speed? Yeah, it'll do that, but the most undesirable is going to be the difficulty to recover from a stalled condition. B. Your aircraft is certified for a few different categories, and when you do your weight and balance, depending on how the weight and balance matches up or lines up, you can end up in either normal category or utility category. If it's a normal category, this is for you to do kind of your regular maneuvers, your takeoffs, landings, steep turn, slow flight, and stalls. But if you're trying to do stuff like spins or other maneuvers, you got to make sure the aircraft is weighed for utility category. A couple things to note, some standard weights. These are the things that when you're doing your numbers, you use these as the basis for how much stuff weighs, like fuel and oil. Fuel is 6 pounds per gallon and oil 7.5 pounds per gallon. Ample example. An aircraft is loaded 110 pounds over the max certified gross weight. If gasoline is drained to bring the aircraft within limits, how much fuel should be drained? Well, first thing we know is that fuel weighs 6 pounds per gallon, right? So if it's 6 pounds per gallon, how many gallons we need to take out? Well, we know we need to remove 110 pounds. And so we divide that by 6 pounds per gallon. And that gives us a number of 18.33 gallons. So the answer is 18.33 gallons. That's how much fuel we need to drain. If an aircraft is loaded 90 pounds over maximum certified gross weight and fuel is drained to bring an aircraft within limits, how much fuel should be drained? Once again, we know that fuel weighs 6 pounds per gallon. So we take the amount we need to lose or drain, 90 pounds, we divide it by 6 pounds per gallon, and we get 15 gallons. Boom, the answer is C. Too easy. Straight, let's